Long after humanity vanishes, Earth keeps its slow, stubborn work going. The oceans drift, mountains erode, and cities melt into stone. Habitats reassert themselves while our traces fade into the geological record. We'll track how life adapts, how climate and continents dance across millions of years, and what remains to tell future observers. Then we'll lift our eyes to the cosmos, where the universe keeps expanding long after our last signal fades. If you're curious about what a world without us can teach about time, resilience, and our place in the grand scheme, you've found the right lens. After humans, immediate global changes. Emissions from cars and factories would drop to zero once humans disappear. The atmosphere would stop accumulating pollutants from daily combustion, and visibility would improve as soot and haze dissipate. Power grids would fail as automated protections shut down. Nuclear reactors would face cooling challenges once maintenance stops and backup supplies dwindle, potentially triggering automatic shutdowns and releases. Cities would fall silent. In the absence of daily maintenance, plants would push through cracks in concrete, and birds would forage in empty streets. Rats adapt. Fields and forests would reclaim roads, with vines draping over railings and wildlife moving into suburban spaces that once felt human-proof. Water and air would shift rapidly. Air quality would improve in many regions as traffic and industry decline, reducing urban smog and particulate matter. Sewer systems fail without power. Untreated wastewater would spill into rivers and coastal zones, altering oxygen levels and encouraging algal blooms in susceptible wetlands. The oceans would continue to respond to long-standing imbalances. Ocean chemistry would drift as CO2 dissolves, causing gradual acidification even without new emissions, while fish and coral communities adapt to altering habitats. Ecosystems would begin new balances. Satellites and weather monitoring would persist for a while, but without humans to fix failures or revise missions, data streams would become sporadic and interpretations would fade, leaving Earth with a quieter but still evolving signal of civilization's absence. Nature's rebound, ecological reorganization and recovery. Without ongoing human disturbance, natural systems begin a rapid retreat of degraded states toward renewed stability, as plants push into abandoned fields and urban margins become green again. Pioneer species colonize disturbed soils. In temperate zones, abandoned farmland often becomes dense thickets of shrubs and young trees as succession progresses. Soil structure recovers as organic matter builds and mycorrhizal networks reconnect, speeding nutrient cycling and helping trees take hold where asphalt once stood. Seeds spread by wind, water, and animals carry life into empty spaces. As the first plants establish, herbivores and predators reassemble their interactions, and food webs rearrange to fit the patched mosaic of surviving habitats. Predators return where large prey is available. In many regions, the absence of human persecution allows large carnivores and opportunistic scavengers to reclaim territory, reshaping grazing pressures and plant communities through top-down effects. Pollinators rebound as flowering plant diversity increases. Cities themselves become laboratories for natural reclamation, with vegetation climbing sidewalks, trees rooting in cracks, and mosses coating surviving stonework. Power lines and rail corridors become aerial highways for birds and insects. Road networks soften as roots crack pavement and water channels reshape drains, creating new wetlands where pavements once channeled traffic. Urban green spaces fuse with surrounding habitats, creating stepping stones for wildlife. Over decades, soil carbon stores may grow as litter accumulates, soils loosen, and microbial communities diversify, stabilizing ecosystem function even as climate interacts with the rebound. Wetlands reform and rivers carve new paths. Yet reorganization is uneven, context-dependent, and shaped by geography, climate, and the weight of past damage, leaving a mosaic that is not simply a return to an earlier state. The result is a dynamic, interconnected world where nature fences keep expanding into human domains. Remnants of civilization, infrastructure, and artifacts decay. Metal corrodes and concrete fractures when left to the elements. Time brings buckled roads, sagging bridges, and crumbling asphalt. Plants push their roots into every joint, and rust spreads across exposed steel. Reinforced concrete yields as moisture and salts work at the steel reinforcement, and surfaces peel away to reveal coarse aggregate. Weather and gravity sketch the first maps of decay, guiding rain into cracks and accelerating hollowing from within. The skeletons of once busy arteries, roads, rails, runways, stand as quiet reminders of reliance. Water infrastructure decays as materials face ongoing moisture and chemical action. Dams and levees crack and seep, pipes corrode and leak. Pools form where treatment facilities once circulated clean water. Coastal systems suffer from saltwater intrusion that weakens concrete and steel alike. Timber piles rot where they touch water, and marine organisms colonize submerged structures, eroding wood and stone. Artifacts endure in some forms longer than others. Plastic persists and fragments into microplastics that drift in sediments and soil. Glass often survives with weathered clarity, though edges dull and surfaces craze. Ceramic tiles and stone monuments weather, leaving pitted surfaces and faded inscriptions. Metals corrode into dull shapes, sometimes forming patinas that reveal the metal's chemistry. Digital remnants exist in unpredictable ways. Magnetic tapes and hard drives lose data without careful stewardship, and data centers left powered down will fail as components fail. In quieter corners, nature and ruin begin to share space. Roots crack concrete enough to widen cracks into small passages for seeds and soil. Birds and small mammals nest in hollowed towers, while vines climb columns and drape over railings. The landscape slowly reconfigures around the stubborn signatures of machines, angled silhouettes, and rusted frameworks that still hint at purpose. The overall picture is not a single moment, but a continuous, uneven process, leaving behind a trail of material choices, maintenance priorities, and the relentless pull of weather. Geological and atmospheric legacies. Our planet would still bear the imprint of human hands long after humanity vanishes. Concrete, steel, glass, and plastics would persist in the landscape, weathering slowly under wind, rain, and biological action while shaping soils and drainage patterns. Roads, foundations, and the hollowed remains of buildings would become embedded in the ground, scarred by roots and weather, and rivers would redraw their channels around these stubborn leftovers. In some landscapes, mining pits and reservoir basins would stand as topographic memory nodes, while litter and discarded materials would migrate into soils and sediments, creating lasting markers of a vanished era. Nuclear waste repositories, if present in the modern world, would remain hazardous and isolated by engineered barriers, standing as contrived landmarks amid a reshaping crust. Geological processes would constantly interact with these legacies, slowly burying, eroding, or reworking them. Rivers and groundwater would move through landscapes altered by decades of excavation, while winds would abrade exposed surfaces and carry debris farther than current sightlines might imagine. Concrete would weather and dissolve locally, altering soils where it sits, while metals rust to oxides, leaving stained seams on rock faces and in soil horizons. In arid and semi-arid regions, salts would crystallize within cracks, pushing apart surfaces and accelerating fragmentation. Plastics would fragment and disperse, slipping into soils and sediments, where they could persist as fragile time capsules and be carried into ocean basins. Layers of plastiglomerates, where plastic fuses with organic and mineral matter, could become unusual but telling components of the future stratigraphic record, signaling a distinct, human-made signature within the natural sequence. Atmospheric legacies would linger in the breath of the air, even as emissions cease. The atmosphere would gradually shed some of the pollutants that darkened skies and cooled surfaces, while greenhouse gases would slowly recede as natural sinks resumed their quiet work. Once aerosols and smoke fade, skies would clear and sunlight would intensify in places that once lived under a veil of particulates. The climate would begin to settle toward a new baseline, shaped by the balance between recovering vegetation, ocean uptake, and ongoing natural variability. Without ongoing combustion, weather patterns would slowly drift toward different configurations, and the rate at which temperatures stabilize would depend on how fast ecosystems rebound and how effectively oceans and soils absorb carbon. In the deep time of geology, the record of this era would be unmistakable. The sedimentary sequence would accumulate signatures that mark human presence. Unusual plastics and glass fragments, metal oxides, and ceramic shards dispersed across lockshores, deltas, and deep-sea floors. Isotopic and chemical tracers tied to fossil fuels and industrial processes would punctuate layers as a dim fingerprint of an era when energy shaped the surface more than any natural process alone. The future geologist would encounter a recognizable juxtaposition: natural rock and sediment interlaced with durable, human-made materials that resist ordinary weathering. Microplastics would pepper remote sediments and even the pelagic zones, a testament to the scale of disposal and dispersion. Over long expanses of time, these markers would blend with natural cycles. Yet a careful eye could still read the narrative of a world that once thrived with human activity, now recast by wind, water, and time. The cosmic perspective, time scales beyond us. Time in the cosmos unfolds across an enormous range, from Planck-scale moments to epochs that outlast human memory. The universe is about 13.8 billion years old. Its expansion accelerates under dark energy, stretching space and pushing distant galaxies beyond reach. The cosmic perspective frames a continuum in which processes from star birth to galaxy growth map onto scales that human life cannot duplicate. Stellar lifetimes illustrate the contrast. Sun-like stars burn for about 10 billion years, while heavier suns blaze briefly and return their enriched material to the interstellar medium. Smaller stars endure longer. Red dwarfs, the smallest stable stars, can burn for trillions of years, much longer than the sun. Galaxies evolve on even longer timescales. Over hundreds of millions to billions of years, gravity reshapes orbits, gas flows, and the architecture of clusters, sometimes triggering new waves of star formation and sometimes winding them down. Gas reservoirs thin out. Eventually, most galaxies become quiescent, with aging stars and fading spirals, while gravity preserves dense cores and black holes. In the far future, the brightest objects fade and the cosmos grows quiet, with white dwarfs cooling and neutron stars turning into simple fossils. Black holes linger. The last stellar remnants slowly lose mass and evaporate through quantum processes, a cascade that, though still theoretical, extends far beyond the current age of the universe. Entropy climbs. With stars dimmed and gas sparse, the universe drifts toward a cold, dark equilibrium where new structure becomes rare. From this vantage, the timescale of human existence seems minute and provisional, a single blink within a vast, slow-moving tapestry. The cosmic perspective, time scales beyond us, describes this long view, and it sits at the heart of discussions about the universe after us. Our measurements anchor only a tiny fraction of it, because the furthest epochs lie beyond the reach of any instrument we can build. The cosmic microwave background continues to cool and stretch, a faint whisper of earlier ages. Time scales beyond us shape what can be observed, what can be inferred, and what might endure as a memory of life after us. Here's the closing frame. In the universe after us, we traced a world without humanity and laid out the core takeaways. Without us, cities crumble and nature reclaims ruins. Our built world dissolves into sediment and memory, while some traces, like durable plastics, buried records, and the stubborn footprints of satellites, linger for long stretches of geologic time. Life would continue to adapt and diversify, ecosystems shifting toward new equilibria. On the larger stage, the cosmos keeps its slow, unfeeling cadence. Stars burn, planets drift, galaxies evolve, reminding us that time far surpasses any one species. If this sparked a sense of wonder or a new perspective on our place in the universe, you're not alone. Maybe you felt a quiet pull to look up at the night sky a little differently, or to consider what we leave behind when we're gone. That connection is what makes these questions worth exploring together. If you enjoyed this, a like or a subscribe would mean a lot. And first, I'd love to hear your thoughts in the comments. What image of a distant future interests you most? Or what part of this long view you want us to unpack next? In future episodes, we'll dive deeper into the long tail of civilization. What remains of Earth's monuments after millennia? How space probes become time capsules? and how future observers might interpret the signals we once sent. Thanks for watching, and first we'll see you in the next exploration.